Happy Friday, everyone. It is Mr. Haney, of course. This week is an exciting week because it's finally you guys' time to shine, parents and grandparents. We are doing addition using the standard algorithm. Up until now, the students were not supposed to have seen the standard algorithm, technically, because all the math that we do up until this point builds up to them learning the standard algorithm. If you've already taught them using the standard algorithm because that's all you're used to, that's fine. I saw a whole lot of them were already kind of using it. But either way, let's just go through it. I'm going to connect this to the things that they were supposed to have been learning before this, and hopefully this will be a short video. So I gave them this sheet. We've gone through the whole thing together, but I'm just going to use one as an example. We are going to be doing some regrouping. Let's see, let's just do this number 4. I see at least a couple places we'll have to regroup. Let me rewrite this on the back. We have 72,156 plus 56,257. We have it set up like this. The students are used to, let's say back when they were doing 3-digit numbers, plus 3-digit numbers. 256 plus 184. They would not have seen it stacked like this. They would have seen 256 plus 184. And then what they would do is they would write these in expanded form. 256 would become 200 plus 50 plus 6. 184 would become 100 plus 80 plus 4. They would add all those together, but they would, of course, start in the ones. Even before this, they had many other things that led up to it, but this is designed to point them toward the standard algorithm, and I think you'll see why as soon as we go through it. So you have your hundreds, your tens, your ones. They used base 10 blocks to represent all this. You had 2 hundreds, 5 tens, and 6 ones, and then you had 100, 8 tens, and 4 ones. 1, 2, 3, 4. So they actually had the physical blocks to use this, but they also would have drawn it like this. So to combine these, you can just kind of circle them together, something along these lines. We have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these, which actually makes a whole nother 10. So we would get rid of all this and add another 10 to our group of 10s, which means we have 0 ones left over. Then you count your total 10s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So a total of 14 10s. But if you have 10 10s, you make a new 100. So we can take 10 of these 10s, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can take these and turn them into 100 and get rid of it. And so you have another 100 over here. So we've just got 1, 2, 3, 4 10s left over. And then you've got your 4 hundreds. Same thing down here, but with numbers as more abstract this way, by getting closer to our standard algorithm. So 6 plus 4, you have 10. But you can't have more than 9 in any given place value. So if you make a 10, you're going to get rid of that. You have 0 ones because you're giving the 10 over to the tens place. Now you have 10 plus 50 plus 80, we get 140. Add those. Check my math, been a long day. Okay, we're good. Then, because we can't have over 9 of any given place value, 90 in this case, if you get 100, you're going to take that 100, bring it over here. Whatever is left over, you leave in that place value. So they now have another 100, and you have 100 plus 200 plus 100 and get 400. 400 plus 40 gives you a total of 440. And hopefully you can see kind of how these connect. 6 plus 4, we would just put a 0, and then you used to hear your teacher say carry the 1. You probably said it yourself. But that 1, this is the really important part about what I want you guys to make sure to do when you're working with your students, your children on this. We used to say carry the 1. I wouldn't say carry the 1. Nothing wrong with it necessarily, but carrying the 1 gives the idea that this is just a 1. It's just a digit 1. But this 1 is not a 1. It's a 1 in the tens place, which tells us we have 1 10, just like you see here. This is 10. It's not a 1. It's a 1 in the tens place, so it's 10. So when they're adding these, they don't just need to be thinking 1 plus 5 plus 8. For quickness sake, for doing this quickly, they might want to just think about it as 1s. But when we get our answer, we need to be thinking about tens and hundreds and thousands and etc. For our answer to make sense. But anyway, you add these, you have 6 plus 8, 14, we would put our 4, and then we used to say carry the 1, but really we're putting we took our 140 out of our tens place, kept 4 of those tens, 40, and gave the 100 to the hundreds place. So now we have 400s, so you have 440. Same thing up here. I'm not going to go into all the base 10 block stuff, and I really don't want to expand this, but just for the sake of what I showed them, this is 70,000 plus 2,000 plus 100 plus 50 plus 6. This is 50,000 plus 6,000 plus 200 plus 50 plus 7. To do it in expanded form, you can see all the things that you're going to need, clearly, like you're working with hundreds and thousands and 10,000s, and it's nice to see that. And some of the kids like that, but I really attempted to show them that this works well when it's 3 digits, but when you get up to 5 digits, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 extra zeros just writing out the problem. So it's ridiculous. So we don't want to do this way, if at all possible. But just for the sake of the video, I'm going to do it one more time. 6 plus 7, we get 13. Can't have 13 here, so we're going to leave that there. We get our 10 up here. 50 plus 50 is 100 plus 10. We have 110. Can't have 110 there. We take our 100, put it up here, which leaves us with 10. Add those together. We have 400 here. We can have 400. You just can't have more than 9 hundreds in the hundreds place. So we don't have any regrouping from here to here. 2,000 plus 6,000 gives us 8,000. 70,000 plus 50,000 gives us 120,000. This kind of threw the kids off when they got to this, but they figured it out. So 120,000. You could break that into 100 plus 20,000, but just, again, for the sake of video. And then we add all these together. 128,413. Connecting it to the standard algorithm, and I'm done. Let's make it under 10 minutes today. 6 plus 7, 13. We put our 1 in the ones place. 10 in the tens place. Regroup is what we call it. Regroup. 5 plus 5 plus 1. We have 11. Can't have 11 in the tens place, but we can have 1 10, and we can move our 100 that we made up here. 1 plus 1 plus 2, we have 4. Don't forget the comma to show the thousands place. 2 plus 6 is 8. And then a lot of students called me to their desk when I let them work on this on their own. 7 plus 5, Mr. Haney, 7 plus 5 is 12, but we can't put up past 9 in the place value, and then there's nothing over here. And I would say, exactly, but if there was something over here, you would regroup, put your 100,000 up there, and then you would bring that down, add it to whatever's there. But since there is nothing, we just have our 2 10,000s and our 100,000. So you get 128,413. Hope that was helpful. Once again, it's your time to shine. Do it. Enjoy it. Have a great weekend.